Howdy folks! If you watched the last video, you saw me analyze a unknown sample that was sent to me by a friend for the cation, or the metal, and I came up with manganese. And I thought I would, for maybe some bonus extra credit, try to figure out what the anion is. And I don't do a lot of anion testing on the channel, so I thought it might be kind of interesting. And the other thing is I'd like to try this book too. It's not a rock or mineral related analysis book, but just a kind of more chemistry. And it covers 13 different anions, anything from, let's see, acetate, sulfate, phosphate, borate, arsenate, nitrite, chlorine or chloride, bromide, iodide, sulfide, carbonate, sulfite, and chromate. So hopefully it's one of those. So we'll give it a whirl. And the book says that there's not really a stepwise procedure of testing like there is for the cation, where you take the sample and you keep going through these steps, but it's more of a bunch of individual tests that you do. So this reference actually has 3 different procedures that are just kind of a general look at the anion. It doesn't, it's not a specific test for a specific anion. And the one test actually uses the solid material, and you put some concentrated sulfuric acid onto it, and you see if it effervesces and what the gas might be. So that kind of narrows it down to what it could be. The second one is a silver nitrate test that precipitates out different materials or not. And the other one uses a barium chloride. So we'll give those a try. First, take a small it's just about the quarter size of the end of a spatula into a test tube of the dry material, and we're supposed to add a couple drops of concentrated sulfuric acid and note whether it effervesces. And if it does, you can check the pH with wet pH paper, which I have standing by. I also have wet lead acetate paper, which will test for sulfide. It's not part of the procedure, but I did it anyways. And then heat it too and see what kind of gases are given off. Boy, I can't even see it. I guess when they say semi-micro analysis, they're not kidding, because it's hard to see. But I don't see any effervescing or anything going on there. So I'm going to heat it just to see if there's any. I think it says look for brown gas, so let's try that. It says heat it, but not to boil the sulfuric acid, and I don't see any fumes. So the anions that don't effervesce include chromate, but that changes color, so that's not that. But the other ones that have no reaction are acetate, sulfate, phosphate, borate, arsenate, and I think I might have said nitrate, but that's nitrate. Fortunately, I saved the water-soluble sample that I made for the cation testing. Let's do the silver nitrate test too. I know silver nitrate will precipitate out the chlorides, but I guess it will precipitate some other stuff out too. But we'll add a drop of silver nitrate to that and see what happens. And it looks like nothing happens. So what that tells us is that there is no chloride, bromide, iodide, sulfide, arsenate, phosphate, chromate, carbonate, sulfite, or borate. So those are definitely absent. Now we make it slightly alkaline with ammonium hydroxide. Alright, that's definitely basic. So here we centrifuge and discard the precipitate. We just keep the solution. Now we add a drop of barium chloride and look for a precipitate. Oh yes, we have one. And it's white. If it was a yellow precipitate, it would be chromate. But since it's white, it's either sulfite, sulfate, carbonate, borate, phosphate, or arsenate. Now we make this acidic with 2 molar hydrochloric acid. Okay, so that's acidic. And the book tells us that if the precipitate dissolves completely, the absence of sulfate is proved, but however, if it is not completely dissolved, the presence of sulfate is proved. So I guess this screening method actually gave us the answer here. It actually narrowed it down to sulfate. Hopefully you can read this, but this is a summary of our anion screening. We started with the dry sample and concentrated sulfuric acid, and we didn't get a reaction. No gas was liberated, no effervescing. So that, according to the book, was either acetate, sulfate, phosphate, borate, arsenate, or nitrate. So that took it from possibly 13 down to 6 anions just by doing that test. The next thing we did was took the solution with sodium nitrate, or I'm sorry, with silver nitrate, and we didn't get a precipitate. So that eliminates a lot of stuff, and the only thing it could be was the acetate, sulfate, and nitrate, which is actually still possible in this group too. The next thing we did was we took the solution and added barium chloride in a basic environment, and we got a white precipitate. So that indicated that it could have been a sulfate, carbonate, borate, phosphate, and arsenate. So at this point, the only thing that's in all 3 possibilities here is the sulfate. Nothing else matches. There's no nitrate or no acetate there. And then we took the solution and we made it acidic, and we still had the white precipitate. So this is actually the confirmation test for a sulfate, is adding barium chloride to an acidic solution and precipitating out barium sulfate, which is insoluble. So, so that confirms that it's a sulfate. So that was interesting. Well, it looks like I got off easy again. The sample procedure seemed to go pretty quickly to come out to the answer. But even so, doing these 3 screening tests, it would definitely narrow things down to at least a handful of candidates that you can go back and do confirmation tests on rather than the whole list. So anyways, thanks again for watching the video, and thanks again to my friend for the sample. I got double the mileage out of it. And happy rockin' mineral identification.